Hello everybody and welcome back to another video on my channel. Yeah, basically I'm not so much into overclocking stuff, but on Vogons forum I found a thread about the fastest 486 setup, and a user named the Serpent Rider was posting an AMD X5 at 180 MHz. It is well documented in this thread, including benchmark results. Especially the Quake result with 19.4 frames was impressing me a lot. Although he didn't post any videos, I believe the values are real due to given screenshots there. Yeah, at the end of his post he wrote, "And now try to beat my scores." Well, this was a trigger for me to do so. After a lot of researching in the web, I could not find another documented benchmark which got higher values on a 486 CPU. And Serpent Rider, if you see this video now, take a drink, lean back and enjoy how I beat your records now. But first, let's have a closer look at the motherboard. I got here the M919 from Chips and Technology revision 3.4b. Yeah, this is a very late Socket 3 board and has the latest UMC Socket 3 chipset. On the date code we can see 43rd calendar week of 1996. So actually 1996 we had already the Pentium around. So this board is extremely rare and hard to find, and in the community it is well known for overclocking and its very good performance. The frontside bus can be set from 20 to 60 MHz, and the AMI BIOS is supporting all variants of Socket 3 CPUs. We got here a VESA local bus socket as well as 3 PCI slots. Of course IDE and floppy support and 4 72-pin RAM sockets. The board supports fast page memory and EDO RAM as well. Yeah, a unique difference to other Socket 3 boards is the level 2 cache. It comes on a small PCB as we know it already from early Socket 5 Pentium boards. But this one is not compatible to the Pentium ones at all. You really need to have the original one. Of course we need a CPU as well today. An AMD X5-133. So this is basically the latest real 486 CPU on the market with 133 MHz. But due to the fact that we have to go up to 180 MHz, so this is 35% of overclocking, most of the CPUs will not run at that speed. I was testing about 30 different CPUs until I found one which was working stable under 180 MHz. Well, there are a lot of rumors around which one are the better ones, with ADV behind or ADZ models or with later date codes, and I can tell you all that doesn't matter at the end. The one I have here is the ADV version with a date code of calendar week 29 1996. Yeah, the thing is, you need to find one where the silicon die is taken from the middle part of the wafer. So I got here a wafer with a lot of dies on it to explain you that a little bit. Due to many different processes during manufacturing, it's etching, lithography and a lot of different processes, the chips, they don't have an equal quality on the wafer. The dies in the middle of the wafer are always the best ones, due to the fact that the manufacturer needs to ensure, in this case AMD, 133 MHz for all chips on the wafer having a high yield. The chips which are outside of the wafer needs to cover the specification limits. That means at the end that a die from the inside is much farther away from limits than the ones from the outside. And exactly because of that you will always find one AMD which is running stable at 180 MHz as long you have enough CPUs to test. For the video card I choose the Creative CT6610 Video Blaster. It comes up with 4 MB of video memory and was produced in the late 1997. After a lot of testing it turned out that this video card can give me the best results for my benchmarks here in this mainboard, and it is running stable at all frequencies I can set here on the board. Yeah, that we have something to compare. We will first build up the setup as a standard setup with 133 MHz, with standard BIOS settings, and with 16 megabytes and 60 nanoseconds fast page memory, and performing all the benchmarks. Yeah, after that we will go then up to 180 megahertz, we will do some optimization in the BIOS, and I will show then without a cut in the video all the benchmarks to prevent anybody saying I faked the video today to get my record. So then, yeah, let's build up the setup. And here another very helpful tool for retro builders. This is a device which is measuring the clock speed of the PCI bus. Yeah, you never know what is really going on after some changes to the PCI bus clock. Yeah, also for this video the tool was very helpful for me. I got this from Atheatos. He is a brilliant engineer and runs a small YouTube channel. He did already some very interesting videos as Tillamook overclocking or introducing this PCI clock measuring thing. He engineered that entirely by himself, and if you are interested you can find on his channel a link to his online shop where he sells these tools for €30. So I can definitely recommend to pass by his channel and give him some love. Yeah, all needed links you will find below in the description. You may also ask what I'm taking for cooling the CPU. Well, for tests like that I don't put too much effort into that, and I just place a huge heavy heatsink on the CPU, and this is more than enough. All jumpers are set now according to the tables. Here these three jumpers, 33 MHz for the frontside bus. We have a multiplier of 4 to reach our 133 MHz. This small jumper here to set the voltage for the CPU, in this case 3.3 volts. So then let's switch on. And interesting, we could see here 16 something megahertz, and now it was jumping to 33.36 megahertz. Very interesting to be able to see this behavior of the bus clock with this device. So nice, on the beginning we have this nice logo, Creative Graphics Blaster Extreme, and let's first check the BIOS. So we have here American Megatrends, copyright 1994. So this is a quite nice BIOS with some kind of windows, how it looks like, with just standard configurations. Advanced, so what do we have here? All this usual stuff. I think chipset is the more interesting part. We have here the auto configuration of all these memory timings. So for our first tests in the standard setup, we leave it as it is, an auto configuration. Level 2 cache right back, and all this stuff. So here we have also an option for the onboard DRAM type, and this is here set to normal. We could also set it to EDO RAM, but the EDO RAM we are using later on for the 180 megahertz. So then save changes, and let's boot this thing up now. So we can see here 256 kilobytes of cache and 133 MHz CPU clock. For benchmarking, I'm using, of course, the benchmark pack from Phil's Computerlab as reference for anybody who wants to get also these results at home, which benchmarks I'm using here. First, let's start with speedsys, of course. We get here a CPU score of 50.18, an average throughput of 109 megabytes per second for the level 1 cache, which is already not that bad for a 133 megahertz CPU. Level 2 cache at 36 megabytes per second and a memory throughput of 27.45. Then let's do all the 3D benchmark testings. So we start with 3D bench. Yeah, and I will speed up the video now that we can come faster to the overclocking part. The results in the standard configuration are already not so bad. This comes from the really good choice of the video card, I guess. 13 frames for Quake, already also not that bad, but far away from the 19.4, which is the value I need to beat today. But now it's time to move on with our overclocking. Yeah, the target is 180 MHz, and for that we need to consider a few things. First is the voltage. Yeah, by overclocking so much, we need to increase the voltage a little bit. In this case, on the board, it gives us the possibility to set it to 4 volts instead of 3.3. Yeah, it's above the specification of the CPU, and I can hear you already. Why are you stressing vintage CPUs? Well, I think for this test and the record here, it's fine. The next thing is the multiplier. To reach 180 MHz, we need to set the frontside bus to 60 MHz and the multiplier to 3 instead of 4. But there is something interesting I found out. The board is automatically limiting the PCI bus frequency to maximum 33 MHz. There's a built-in divider which is dividing the clock by 2 as soon you set it above 33 MHz. Let me show you this. I set now the board to 40 MHz, that I can show you what I mean. So let me switch off the light that you can see the display a little bit better. And let's switch on. We can see now 40 MHz here for the bus speed. And now it's jumping back to 20 MHz. So this divider by 2 is working properly to save the cards from back in the days. So the specification was 33 MHz maximum on the front on the PCI bus. And the cards back in the days, the video cards, they could not hold much more than these 33 MHz. So then let's switch on the light back that we can see something. Switch off the computer and I will show you something interesting now. I will put the jumper back for 33 MHz, and to come to 40 MHz we need to remove this jumper. If I switch on now the computer, we are back at 33 MHz, and let's wait until we have our boot screen. Now, and if I remove now the jumper to 40 MHz, it's remaining at 40 MHz. So that means if we make a hot plug switched on and making the settings for the frequency, the divider is not working at all, and the bus speed for the PCI bus is remaining at the set speed for the frontside bus. So this is quite a very important topic that we can reach our record values by today. The same I'm expecting then for the 60 MHz we need to set. The right setting for 60 MHz is one jumper here in the middle. But to put here straight away a jumper, this would cause a 30 MHz bus speed, 60 MHz divided by 2. But I want to have 60 MHz on the PCI bus to get the maximum performance out of the video card. You might say now, the video card cannot hold 60 MHz. No, this card can hold 60 MHz. The same version is existing for the AGB bus. Therefore, this chip can hold also 60 MHz. But to reach that, we need to trick the board again as we did it before with the 40 MHz. For that, I assembled this small switch, which I can put directly here on the pin headers to make a hot plug much easier. So then let's try this and see the behavior. I set now the switch to on. This means one jumper is installed. This means 60 MHz frontside bus. So then let's switch on. And we can see now 60 MHz here, and now it's jumping back to 30 MHz. So the divider is working as expected, as we saw it also before with the 40 MHz. So then let's switch off the board. Now we switch off also the switch. This means no jumper is installed right now. And let's switch on the board, and I expect here to see now 20 MHz. Yes, we can see now 20 MHz. This is the configuration to have no jumper installed here. But the interesting thing now, again, if we go back to 60 MHz, is remaining here 60 MHz. So we need definitely to do this hot plug to reach our maximum performance possibilities here on the bus. To get a stable running system we need also a proper RAM. Instead of the fast page memory we will use now this 16 MB EDO RAM with an access time of 50 nanoseconds. So I am ready to go now to make all these benchmarks at 180 MHz. As I mentioned already before, from now on I will not cut the video anymore to avoid that anybody can say I was manipulating here something to show here these good frame rates at the end. So we have here our CPU. This is switched to off, that we can tweak the frontside bus later on to 60 MHz. Here we have our changed RAM to the EDO RAM. Yeah, and everything fine so far. Just need to place here the heatsink and we can switch on. Of course we need to go to the BIOS first. Let me move the camera. We still need to modify the settings for the memory in the BIOS. So now we should be at 20 MHz. Yes, the display is showing that. So chipset. So what we are going to change now: auto configuration disabled, cache speed options to the fastest, DRAM read wait state 0, DRAM write wait state 0, PCI clock a third, keyboard clock half. So unfortunately the level 2 cache mode we need to set to write through. In the write back mode the system is not that stable and it can crash, and I would like to avoid that. But nevertheless I will beat anyhow all these existing benchmarks. So here on board DRAM type we need to set to EDO because we installed the EDO RAM, and that's it. So we can save now that and boot up the computer. Sorry for waiting a little bit in between, but yeah, I don't want to cut here something, that everything is clear at the end. So I will also switch now to 60 MHz. So I dropped now. So everything is booted up now, and we will start with Phil's computer bench. First, of course, speed sys. So let's wait a little bit. Yeah, and we can already see here it's showing AMD 486 X4 180 MHz. Also very interesting, we get a video memory throughput of 65 megabytes per second. So this is an insane value, and of course because of the 60 megahertz on the PCI bus. So the CPU rating is 67.79. So this is also a quite nice improvement what we saw before at 133 megahertz. So then let's wait until the benchmark for the memory throughputs is finished. It's going actually very quick with this 180 megahertz. So I can tell you the system is running completely stable with this configuration I have here right now. So there's nothing I need to trick here. So this is finished now. We have a level 1 cache average throughput of 169 megabytes, a level 2 cache average throughput of 83 megabytes per second, and a memory throughput of 68.73 megabytes per second. So this is quite nice. We can also check out directly everything from the memory. You can see here read, write and move, there are different values, and the average value is that what we saw before. So then the next one is 3D bench number 2. Let's start. So this is going very fast now, and we have here 120.8 frames. So this is absolutely for sure the highest value I have ever seen so far on a 486 computer. So this is really insane. So then let's go to 3D bench. We had already, so we have the Chris 3D bench in 640 by 480. It's number 4. So if you remember before we had here, let me check, 16.6 frames we had before. So let's see what we can get now with 180 megahertz, and the optimal settings for the RAM. So this takes a while. So now we are done. We get here 26.3 frames per second. So this is also a very, very good value for the Chris 3D benchmark in 640 by 480 on a 486. So the next one is PC Player 640 by 480. This is number 6. And let's see what we can get out here. So this graphics is a little bit more complex. I expect here a little bit lower value. And we can get here 12.5 frames per second. So this is also an extremely nice value for a 486 setup. So 12.5 frames. So the next one is already Doom. So number 8. And let's see what we can get out of Doom here. So Doom is basically limited to 35 frames, therefore it's going quicker than usual through this benchmark here, because we are obviously above 35 frames. So it will be soon finished, and we get here a value of 1048 real ticks and 2134 game ticks. So this means at the end we calculate 2134 divided by 1048 multiply 34. This is the rating of Doom. We get here 71.26 frames at Doom, which is also an insane value. Nice. So the next one and the important one is Quake, number 9. So Quake is very CPU demanding, especially floating point unit demanding game. And yeah, so to play Quake on a 486 in a decent frame rate is almost impossible. And as I mentioned before, the record of this guy from Vogons was, let me check again, 19.4 frames. And yeah, let's see what we can get out of this machine here. But 19.4 frames this guy had is already an insane value for a 486. So yeah, I will be happy with any value above this 19.4. So now we are done soon, and we get it, 20.8 frames. So ladies and gentlemen, 20.8 frames on a 486 setup. So this is really definitely the highest documented value I have seen so far on a AMD X5-133 megahertz overclocked to 180 megahertz. So I'm really happy with this result, and yeah, unbelievable. And you can see the system is fully stable running, no cut in the video, nothing at all. Everything is fine so far. Then let's summarize the values. At SpeedSys, the CPU score is at 67.79 compared to the 133 MHz at 50.18. For the level 1 cache, the level 2 cache and the memory throughputs, we can see here really a massive performance improvements at 180 MHz. 3D bench was jumping to 120.8 frames instead of 76. Chris 3D bench at 640 by 480 with 26 frames, almost 10 frames more than on the 133 MHz clock. PC player at 640 by 480 at 12.5 frames, almost doubled here the rating. Yeah, and Doom came up with insane 71.26 frames at 180 MHz. So this is really a ridiculous value on a 486 with the Doom benchmark. Yeah, and Quake, this is the benchmark which triggered me 20.8 frames. This is insane. This 19.4 frames from the Vogons forum, this was giving me so many sleepless nights because I wanted to beat that, and now I got it. 20.8 frames at Quake. This is the benchmark right now and the highest value I have ever seen so far on a real 486 machine. We can see here improvements between 35 and 150% from the 133 MHz to the 180. Nice, very nice. So I claim now to have the proven fastest real 486 setup, at least on YouTube here. I can hear you already, yeah, I know somebody who saw somewhere more, la la la. All that doesn't count. If you can beat these values, make a video, document it by a way that we can see that it's not faked and upload it, or send the video to me. I will publish it for sure on my channel. Basically, I would like to see somebody beating that to give me another exercise and sleepless nights again. Yeah, and we are just talking about a real 486 and not Pentium overdrives or Cyrix 5x86 chips or whatever. The fastest 486, this is what is counting here. I am happy right now. After months of part searching, testing, researching, I reached my goal here until somebody can beat me. I'm looking forward to read interesting discussions in the comments below. I hope you liked the video, and if so, please thumbs up and subscribe. Thank you very much for watching and see you soon.